All right, let's get ready for this test. Unit 5. Let's see. What percent of the squares in the model below are not shaded? So obviously this is important. Not shaded. And then as far as counting goes, I literally just count, like put a little dot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my total is 20. And then we want to do not shaded. Let me get rid of all this. So I would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 out of 20. And then we're looking for percent, right? Because it says right here what percent. So I would do, since percent is out of 100, and this works perfect, right? This isn't too hard to figure out. Times 5, times 5. And then I usually break it up. 10 times 5 equals 50. And 4 times 5 equals 20. And then I add those together. So I would say 70%. Hopefully I did that right. Double check me. All right, number 2. This one kind of looks like a pain. The diagram of the living room is shown below. What fraction of the living room is covered by the rug? Okay. What fraction? All right, so I guess I need to figure out how big the room is first. So if we count the side, looks like there's 6 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the bottom. Okay, and then we have 4 by 5 is 20. So, this one's going to be hard. 20 over 54. Okay. Well, kind of a pain in the butt because 54 won't go into 100 very good. What if we just, maybe we could simplify it to be 10 out of 27, and then maybe just, why don't we just divide? 10 divided by 27, and we'll see what fraction we get. So that's 0, 0, so 27 into 100. Let's see. Well, 27 times 4 would be a little too big, so maybe 27 times 3. 3 times 7 is 21. 3 times 2 is 6, 7, 8. We're going to regroup. We get 19 left over. So let's just add another 0. We'll see what we get. All right. Well, 3 was 81, so 6 would be 166 or something like that. Here, we'll do 6. I think it may be a little too big. 6 times 7 is 42. 6 times 2 will be 12, 13, 14, 15, 16. Oh, we might get lucky, but I don't think so. So close. All right. So I would say not 6. Let's do 7 instead. 7. 7 times 7 is 49. 7 times 2 is 14, 15, 16, 17, 18. So close. So close. And then we could keep going, but it's going to be roughly 37. So I would say 37%-ish would be a good answer. That's a tricky problem. Double check me. Maybe I just read it wrong, or maybe I just didn't do it right. So maybe you can find my mistake. We'll see. All right, using the grid below, determine the decimal representation for the shaded portion. All right, so shaded portion. Let's figure out our whole first. So let me do a little counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our total is 20. And then determine the decimal represented for the shaded portion. All right, shaded portion. So 1, 2, 3, 4, 5, 6. All right. Well, to make it a decimal, right? We're trying to do the decimal. I would actually just go down to 10. We don't need it to be out of 100 since we're not doing a percent. So divide by 2, divide by 2, and we would get 3/10. And 3/10 as a decimal is 3/10. Not too hard. All right. I can show equal parts of a whole. A model below shows how much pizza is remaining. Fill in the blanks below with the equivalent forms of the amount remaining. Okay. So fill in the blank below equivalent forms. Okay. So let's figure out how many we got. 1, 2, 3, 4. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they just want some equivalent forms of this. So I could always go down. I could divide by 4 and get 3 over 4. Oh, not 3 over 4. Silly Mr. Leatherwood. If I divide by 4, I'll get 1 over 4. And then we could just skip count by 4s, right? So we could do 8, and then we could do 12, and then we could do 16, and we could keep on going. And on the bottom, let's see. Did I do that right? I didn't do that right either. Come on, guys. Y'all got to keep me on my toes. So if I'm dividing by 4, I would get 1. If I divide 12 by 4, I would get 3. So then, in this case, I could go from 12 to 24. I could go from, if I did 4 times 3, I got 12. 12 times 3 is 36. 4 times 4 is 16. 12 times 4 is 48. And blah, blah, blah. I could keep going if I wanted. Notice I could also do 2/6 would be 1. I could do 3/9. So all kinds of equivalent forms. So we just picked a bunch of random ones, but as long as they keep proportional, you're good to go. All right, Susanna says that 2/3 of 60 and 60 are equal. Is she correct? Well, we know that 2/3 equals 66 and 2/3%, just like 1/3 equals 33 and 1/3%. So to say that 66 and 2/3 equals 60%, I think she is incorrect. So sorry, Susanna, I think you're wrong. 11 of the 20 students in Miss Gonzalez' science class are attending the field trip. What percent, so we are looking for percent, best represents the portion of class that is attending the field trip? So 11 of the 20 are attending. What percent best represents the portion that is attending? Okay, so no craziness there. They weren't mean to us. So 11 out of 20 are attending. We want percent, so let's get it out of 100. Times 5 here, times 5 here. There we go, 55%. Smiley face with a tongue. There we go. All right, number 8. A stick measures 2 3/10 meters long. Write both the decimal and the percent. So both the decimal and the percent equivalent. Okay. So 2 3/10 would equal 2 3/10. So there's 1. There's our decimal. And then for our percent, I would say 2 equals 200% because every whole is going to give us 100%. And then we have 3/10, which also turns to 30 over 100. So I would say that equals 30%. So add those together, and I would get 230%. Remember, guys, if I'm going too fast on this, you can rewatch it over and over again. You can stop me in class and ask me questions, whatever you need to do. Determine the percent that best represents each point on the number line. Okay, so if you always notice your starting and ending point, then I can kind of label what's in between. So for me, I see that Let's see. That would be 50%. I think this is 75%. This is 25%. That's in my opinion. So in between that, if we go from 0 to 25%, like right, we have 0 to 25. If we cut that in half, I would just do 25 divided by 2. And I think that's 12.5%. Same between in here, if I do 50 to 75, well, if I add 12.5 to 50%, isn't that like 62.5%? And then the last one, I'm going to add 12.5 to 75. And what's that, 87.5%? Double check me. So I think we have 12.5%, right? We are looking for percent. 25%, 62.5%, and I think 87.5%. Double check my math. I did all that mentally. So, but in general, what I figured out is once I figured out this right here, that 12.5, that means every time that I was jumping this small amount, I was adding 12.5. Sorry, my jumps aren't very good. So then that kind of helped me out. So I don't know. All right, I think our last one, or at least for this first video, if the tape diagram below represents 100%, then determine the value of the other representations. Okay. Interesting. I like this one. All right, so this one is 100%. So if we did a strip diagram, that's 100%. So the whole thing. So on this one, we divided it into 1, 2, 3, 4, 5. So if I take 100 divided by 5, that means each one of these is 20. So I would say that this one goes to 60%. And then on the one to the right, I'm cutting it into 1, 2, 3, 4, 5, 6. So if I take 100 divided by 6, they had to pick one that's not very fun. So let's see, 1, and then 6. So we're going to get 16.6, and it's going to keep going. So what I would really do is say 16 2/3% would be each one of these. So this first one would be 16 2/3. Now on this one, the C one, it looks like we have 3 of those. Now I could add those 3, but if you notice, let's say I redrew this. Did y'all notice that it's just half? So I think I would just say 50%. And then on this last one, notice here, right here, we have 1 hole. So that's going to at least be 100% for that first little block. And then this second one looks like it was cut into 4s. So I know that, this is 25%, 50%, 75%. So I would say 175% because we have 1 hole here, and then we have 75% here, or 3/4. So that's my humble opinion. All right, guys, hopefully this was helpful. Hopefully I didn't make too many mistakes. We shall see. But if I did, point them out to me, and we'll learn from them. All right, later.